You're listening to Electrician Live with your host, Paul Abernathy. Well, hello, everybody. Welcome to another episode of Electrician Live, where we talk about all things for electricians. On today's topic, we're going to talk about the top 5 changes to the 2020 code that can affect the residential electrician or contractor. Now, of course, there's a lot more than 5, and there's a lot more changes that could impact you. And again, there's literally hundreds and hundreds and hundreds of them that we could talk about. But we're going to look at moving forward. I want to break these down into top 5, and of course, the next top 5, you'll think, well, why weren't they your top 5? It doesn't matter. We're going to talk top 5 in this episode of ones that I think that residential electricians need to be aware of as they're moving forward once the 2020 NEC is adopted in their area. And so we're going to look at those so we have a better understanding. Now, each one of these topics will probably be talked about in a higher technical level on our Master the NEC forum, whereas I might have graphics and illustrations that discuss these. So we're going to do it at a 30,000 foot view because I feel that in a podcast setting like this, we just want to give you the idea of changes in how they're going to impact you. And that's what we're talking about in this episode today. All right, so the very first change, by the way, my name is Paul Abernathy, and welcome to the podcast. The first change that we want to look at that's going to impact residential applications takes place in Article 230. And there's a couple that take place in 230. There's 3 of them we'll talk about today. But this one has to do with Section 230.85, and that is a new section for the 2020 National Electrical Code. And that is dealing with the emergency disconnect. Now, the emergency disconnect requirement came about in the 2017 code. And by the way, this rule right here does not remove any of the allowances in 230.70A1 for the service disconnect. This doesn't change your grounding and bonding that you've always done. This doesn't change anything in Article 250. Okay, all this is doing is allowing a emergency disconnect to be there, and it has to be outside. And you're going to be given 3 different options to achieve this, or 3 different things that you can do in order to have emergency disconnects. Okay, so we'll look at each one of these. 2 of these directly impact your service, and one is also impacts things like PVs or generators or energy storage systems that might be installed on the supply side of your service disconnect that's allowed by 230.82, okay? So we'll talk about all those. All right, so let's look at this first. 230.85, it's new, and it's an emergency disconnect. Basically, this rule came about. It started back in the 2017 edition as we moved through it, and it was presented by the first responders, the firefighters associations, and things like that, that when they would go to a fire call, and again, 1 and 2 family dwellings is what this rule applies to, and that is probably the largest lion's share of their calls because there's a lot more single family, 1 and 2 family dwellings out there. And the fire calls and how they have to respond really start to mount up. And so when they get there, they have to resort to killing the power on the building so that people can go in there and not being put at risk. Because you got to remember that you've got circuits running through the walls, and as they go through and things are burning, they need to put that fire out. They need to cut through the roof to vent it. They need to do a lot of things. It can be a lot of hazards for them. So many people have used an outside disconnect for their service, for the service coming in for years out in the West Coast. Not so much in the East Coast, but it was done a lot out there. And so this is old hat for them. But this whole concept started in the 2017 code, and they wanted the ability to shut power off to the building without having to go and cut the meter or cut the tab off the meter or yank a meter, and it just puts the first responders at risk. Sometimes they have to go and they'll cut power lines, and they're in such a hurry they might cut them above the meter, but then they don't remember that there's a chance that service drop that goes down onto the ground still could be live and somebody could come in touch with it. There's so many hazards. So how do we eliminate that? Well, the concept here is if you're just trying to get into the building and make the building safe, then let's put an emergency disconnect on it. So it was presented in 2017 code. It just didn't have all the support it needed, or it wasn't ready for prime time. But in the 2020 code, it was successful. And so it created a new section, 230.85, and it's called emergency disconnect. Now, a couple things to keep in mind. This only applies to 1 and 2 family dwellings. So for you residential guys that are doing this, you're now going to have an emergency disconnect on the exterior, readily accessible location on all 1 and 2 family dwellings. It's just a given. You're going to have it. Now, some jurisdictions, some states will probably try to amend that out. And again, it looks foolish because this is a safety. You're trying to protect the first responders. Okay, whether you agree with it or not, it does have merit. Okay, the National Electrical Code is a minimum safety standard, right? So its effort is to try to protect the users of people that deal with electricity and electrical installations. So this is the change. Now, these service disconnects are going to also have to be SCCR, that's short circuit current rated, for the available or greater than the available fault current that's available at their termination. So at this equipment. So you have to obtain the available fault current. You have to make sure the equipment meets that value, or the short circuit current rating, which is the value of the equipment. And again, it has to be installed in a readily accessible location outside. Again, this doesn't change anything in 230.70A1, outside or nearest point of entry for the service disconnect. Okay, this is just giving you some options. You can use a service disconnect and it be outside, and you meet both rules. Okay, but let's talk about the disconnect. All right, so now, again, they're going to be grouped if you have more than one, okay? If more than one disconnect, they shall be grouped. And each disconnect shall be one of the following. So the very first one is probably what most people will do, is they'll use a NEMA 3R rated for rain application, exterior outdoor service panel board that's inside of a NEMA 3R enclosure. And that'll have a main breaker in there. And main breaker is going to meet the overcurrent protection requirements of the code. It's going to be, it'll meet the service disconnection mean requirement. And it's probably, in this case, it is service equipment. So it has to meet the SUSE rating and all that good stuff. So that's your normal outside panel. And then, of course, you feed your branch circuits from there, or feeders from there as you go. And that's outside. And that will now require an additional label on it. In other words, a different wording on it. Instead of it being just a service disconnect now, it also has to have the emergency disconnect to let those first responders know that this is also the emergency disconnect. So it's serving not only as the service disconnect, but it's also the emergency disconnect. And that's fine. It serves both purposes. And that's probably what most people will do. Okay. So the next application is one that's been done for years on commercial applications, not always on residential, and that is to install what's called a meter disconnect. Now, a meter disconnect is not service equipment, kind of like a meter is not service equipment. It is serving as a meter disconnect, but in this case, it's also serving as the emergency disconnect that's killing power to the building for this case. So you're allowed to have the meter disconnect on the supply side of the service disconnect. So that still could be outside or nearest point of entry inside. This is a meter disconnect, and it purely has to be, if this is your option, outside. And what allows that to be on the supply side? Well, 230.82 item 3 is meter disconnects, and that's been around for quite a while now. Now, the thing to remember with this is typically you wouldn't see them on residential. It's usually going to be on commercial. Generally because they want to be able to kill that so that they pull the meter for whatever reason, and they don't know what's going on inside of the building, and so they don't want to pull the meter and make or break it under some kind of load. You might have something inside that's really pulling a significant amount of load, and you have an arc condition, but also the ability, again, to be able to shut it down for an emergency situation. So that's kind of been around. It wasn't a requirement, but a lot of utilities might have required this meter disconnect in the past. So it really wasn't something that was utilized for residential, but now it can be for this application. And it wasn't that it was ever prohibited. It's just now being brought more into light as an option to meet this disconnection means. Now, some people will argue this raises the cost, and it does. But again, it's the cost of safety in this application. And again, you could just put your panel outside with your main breaker and serve double duty anyway if you want. So you do have options. Okay. And a lot of people would do that option number one, the service disconnect, is if they were having to locate the panel further into the building anyway. So they would put the service disconnect outside. It was just a breaker, main breaker. And again, change over to 4 conductors as they go into the structure, and then they could put their panel anywhere they want. And that is a typical application that people have been doing for years because they don't want the panel on that exterior wall. They wanted to move it further into the building. And so you have to change over because we can't have those service conductors extending into the building. All right. They're supposed to terminate outside or nearest point of entry. Right. So that's a common thing that we've done. Now with the meter disconnect, again, the meter is just a disconnect. Okay. It's not service equipment. So you have some labeling that's required. So if you're utilizing the meter disconnect rule, you're going to have to put on there emergency disconnect because that's what it is. It's going to kill power to the building. But it's also the meter disconnect, so you mark that as a meter disconnect. And of course, you got one other requirement that says that it has to be marked as not service equipment. It is not service equipment. It does not change the scheme of your grounding and bonding and everything you normally would do in your system. Okay, so it doesn't overly complicate it. It's a meter disconnect application. Okay, and we're going to leave it right there. Okay. So that's your option for that. If you want more detail, again, I do a podcast or in a video on 230.85 and I cover all those little nuances on supply sides and things you can do on the supply side, but we're going to leave it here at the 30,000 foot view. The next thing is you have the option for other listed disconnect switches or circuit breakers on the supply side. And you might have things like wind generation, PV. Again, also in 2017 code, the requirement for the PV shutoff requiring it to be outside application was something that was introduced. So this kind of goes along those same lines. In this case, if you have a listed disconnect switch or circuit breaker for some other system, one of those that are allowed on the supply side in accordance with 230.82 item 6, that's like PV, fuel cell, wind, electric systems, energy storage, and things like that, or other interconnected electric power production systems, then you would have the ability to use those disconnect switches or circuit breakers also as emergency disconnect for that system that's supplying the building. But again, it also requires you to mark on that it's not service equipment because it's not service equipment. Okay, it might be an emergency disconnect that's allowed to be there to that building because the code allows you to have that on the building. But again, you have a bunch of different options, and that's the new 230.85. Okay, and we're going to kind of leave it at that for that one there. All right, so the next one that we want to talk about is a little change that comes to residential. Make them aware of it. And this isn't just residential, but I figure it's important to kind of highlight it as a residential, is the 6 disconnect rule. So the 6 disconnect rule, where I'm allowed to have, for each service, it would allow me to have up to 6 disconnects located in one location, kind of grouping requirements and all that, and the grouping is 230.72. But it allowed me to have up to 6. Now, in the past, it would have allowed me to have, let's say, a main enclosure with up to 6 2-pole breakers, let's just say. And then, of course, the 1/6 one could be feeding a panel downstream or whatnot. But I could have had a main lug only and fed it, and as long as I didn't have more than 6 breakers in there, then I was meeting the 6 disconnect rule, and that was acceptable in a single enclosure. Well, in the 2020 code, you can't do that anymore. So whether it's residential or commercial or industrial, it still applies. Now, there's some allowances for things like switchgear or meter centers where you have each disconnect is located in a separate compartment. As long as you're killing it in that compartment, then you're okay. But what we're talking about is the significance of people buying a large enclosure that has 6 large breakers in there, and that's no longer permitted anymore, where you hit main lug only. Now, it's still allowed on the feeder side because you have a breaker that's ahead of the feeder that can shut that down. But when it comes to services, that rule's not there. Now, you still can have the 6 disconnect. They're just located in separate enclosures, okay? All right. Or, again, you can have it in a panel board as long as the panel board has a main service disconnect means in that panel board, okay? And then each enclosure has a main breaker. You got those options as well. But what's the significance of this? Well, even though you met the 6 disconnect rule and we could shut it off at 6 throws of the hand, the bus was still alive. Okay, so it gave the false impression that you killed the panel board inside of this enclosure, and you really did not. And so if you were working in that enclosure, you still had the risk of coming in contact with a live panel board, the actual gut system. And so you didn't kill anything. Now, when you're dealing with switchgear or motor control centers, if you're working in that single component and the disconnect that shuts it down is in that that separate enclosure compartment, then when you're working in it, you're effectively killing everything on the load side of it, so you're okay. I mean, we're okay. But when you're coming to a single enclosure, that wasn't necessarily the case. And so this rule removes that ability to be able to meet that 6 disconnect rule in a single enclosure. Okay? And so it's significant when it comes to safety, whether you agree or disagree with it. Again, if I'm shutting down that bus, I mean, a couple cycles ago we implemented, it might have been last cycle, we implemented where you had to use a separate barriers on the supply side lugs in order so you don't inadvertently come in contact with it. Same concept, we're trying to isolate the live parts, and in this case, if somebody shut that off, or turned a breaker off and pulled that out to do some work on it, the bus is still alive. And so it was an unsafe condition. So now this is just an effort to make it a safe condition. So that is 230.70A1, 230.71A and B, which has been redone. So the general rule is you have a service disconnect in your panel or your enclosure. And then, of course, you have the allowance for 2 or more. But they have to be in separate enclosures or separate compartments of switchgear or metering centers. Okay, and of course switchboards also is in here as well, and they're a little different than switchgear. Okay, so you do have some allowance there. Now in switchboards it says switchboard where there are only one service disconnect in each separate vertical section where there are barriers separating each vertical section. So if you're dealing with a switchboard, you have different compartmentalized vertical sections. If you have a separate disconnect in each one of those sections, then you're okay. Otherwise, you'd have to have the main disconnect that shuts it all the way down if you didn't have that option in each one of those separate sections. Okay. So anyway, I encourage you to go read 230.71B, and we do have a podcast and video that explains that in even more detail. But that's a significant change because you need to be aware of how this impacts you when you're going out buying main lug only panels and how they might be utilized. Now, that's just something to be aware of. Now, the next one that we're going to look at that's going to impact cost to the residential electrician is 230.67. Now, 230.67 deals with surge protective devices, and that's a new section. Now, surge protective devices aren't new to the NEC, but they are new to this aspect when it comes to services in a sense that now dwelling units are going to be required to have surge protective devices installed. Now, they're either going to have to be integrated with the service equipment or immediately adjacent. Okay, and so you do have an exception to the rule that says, well, if it's not interconnected with the service equipment and it's not immediately adjacent, and we won't argue the distance that's considered immediately adjacent, but my ruling on this, if there's space right next to the panel to put something, then that's immediately adjacent. That's where it needs to be. Not 10 feet down the way or 5 feet down the way. It needs to be right beside it. Okay? So, again, if you're looking at that and that's your interpretation of it, they do have an exception that says, well, tell you what, if you have the panel and it feeds a remote distribution panel downstream, I'll let you put it in that remote distribution panel. Okay? I'll let you put it there. Okay? And so that's the exception to that rule. And that's called a next level distribution equipment downstream. Okay, so you read that part of it, then you've got that allowance. That's the exception to the rule. But let's get back to the general rule, and that is in your service equipment for dwelling unit applications or immediately adjacent. Now, what type of SPDs can you use? Because there's many types. There's type 1, type 2, type 3, type 4, and even a type 5 type of SPD. Well, we're talking about type 1 and type 2. Now, typically type 1, and again, you can go read the definition of SPDs, and Article 100 gives a good definition of that. But type 1 is typically ones that would be on the line side, and type 2 would be on the load side of your application. Maybe the kind that plug into the panel board or is immediately adjacent, or one that you buy that wires directly to a breaker that's inside of the panel enclosure. And that would be immediately adjacent because it either connects right to the side of the panel board, and in some manufacturers, they even make it where it's integrated into the panel board. Okay. Is a little space that you mount it inside of the actual cabinet, and then you wire it to the breaker, keeping those lines as short as possible, because lightning and surges don't like a bunch of loops. They want to keep it short as possible and as straight as possible. But again, follow your instruction manuals for the product. So type 1 and type 2 are SPDs that you use. Now, here's the interesting thing for replacement. So this is the code usually doesn't get that much into the replacement aspects, although we did see that for receptacles. We replace a non-grounded with a grounded in places where AFCI is required, and you change it or extend a circuit, you have to change it to AFCI. And we see some of those type of remodel type of replacement stuff. But here you've got a requirement for replacement for these SPDs. If you do any type of replacement of the equipment, of a panel, service equipment, if any replacement, you're going to have to put an SPD, type 1 or type 2. And why do we want this? Well, there's so many more sensitive electronic equipment today in our enclosures that, not in enclosures, but in our equipment that we're dealing with, like GFCIs, AFCI circuitry, overload systems, and a lot of equipment that we have. All the new technology that are designed to protect us as we interact with it. And it's also sensitive electronics. And so we can get spikes and surges from things that are contributed inside the building as well as outside of a building. And that's also true for single-family dwellings, two-family dwellings, or any type of dwelling unit application. So this is trying to protect those devices that actually are there to protect us. And that's the effort here. So we've seen a steady expansion, if you will, of SPDs and where they're required. And here's just another venture into that. So they're not overly expensive. They add cost, but again, they are in an effort to protect those devices downstream that can be safety devices. Okay, so there you go. So in a replacement, if you're upgrading, swapping, even a like for like, if it's a replacement, then guess what? You're going to have to install surge protected devices as well in that application. All right, so the next thing, again, maybe not ideally a top 5, but it is something significant that I like to talk about because it has to do with GFCIs, and it is 210.8a, and it's dealing with the change when it comes to basements. So prior to the 2020 code, you're required to have GFCI protection in an unfinished basement. Now, people argued what was considered unfinished, whether it was concrete floor, whether it was gypsum board on the wall, whether the ceiling was finished with some kind of drop ceiling or gypsum board. The argue over what was considered finished or unfinished was hotly debated. Now, again, people like me will argue that's okay, but we'll leave that up to the AHJ to determine that. Because I've seen a lot of really fancy homes with the concrete that is finished concrete, okay? So I wouldn't consider a basement with a finished concrete or sealant on it or whatever to be a key component in whether something's finished or not. Now, if the studs are wide open and you can see all the wiring and everything in the wall, then that's unfinished. If the ceiling has... there's gypsum board on the walls and it has concrete floors, but the ceiling is open. I don't necessarily know that I would consider that as unfinished because I'm more worried about what I would come in contact with, and that is the walls and the wiring around the walls and the things on the floor. Up in the ceiling, I pretty much have to get on a ladder or something to get to. So again, every jurisdiction was different. Everybody had their own ruling on that. Well, in the 2020 National Electrical Code, it's now across the board. Any receptacle, and again, 210.8 is a receptacle requirement. Don't ever lose sight of that. Is the fact that, and when we say receptacle requirement, 210.8a is a receptacle requirement. I mean, I should clarify that a little bit better than what I said. Is the fact that GFCI protection is there to protect us. And I think that was their effort, and that was what their goal was. But you know what? I've seen plenty of basements that were finished that have waterproofing. That those basements will never leak, ever. And so what scares me with this change, and again, I don't want to inject my opinion, but you're not prohibited from using GFCI everywhere on brand circuits. Okay? I mean, to be honest with you, you're not prohibited on feeders as well when it comes to dwelling applications. But and one of those things about it is that I don't know if that's overreaching because, again, unfinished basements, I get it. Finished basements, what level of basement that's underground becomes finished or partially underground or whatever it is. But now, what's considered a basement? What percentage of it's underground? Is it a basement? But in this case, all basements at this point are going to require GFCI protection on the receptacles. Again, we're talking dwelling units, we're talking A, and that's a receptacle requirement. All right? So that's a change. Just remember that. Again, quick fix if you screw up with that one is just got to put a breaker in that's GFCI protected and protect the circuit that are in the basement. There you go. Again, receptacles. We're talking receptacles, not lighting, receptacles. The only other change that I'll talk about in this one, since we're already at it, is item number 11, which now incorporates indoor damp and wet locations are required to also be GFCI protected. Mud rooms necessarily didn't fall under this requirements, but a lot of people in mud rooms will have areas that really wasn't qualified as a tub. It wasn't a sink, but it was an area where you could wash down the dog and whatnot, and you might have receptacles there. So jurisdictions might consider that an indoor damp or wet location because you might spray it down or this type of thing. So in this case, it would require the GFCI protection on those receptacles if it was an indoor damp or wet locations. We'll let the HGA determine that. All right. Now, the only other change that I want to throw in here, and since I'm already here, I will talk about a change that took place, and it's just dealing with outlets. And we're not talking just receptacle outlets. We're talking all types of outlets. A point where we take power from for utilization equipment. A point where we access that power to take it over to equipment, for example, is an outlet. It could be junction box, an outlet. You could have a receptacle. This is a device that mounts in an outlet box. Whatever. We're talking about a point where we take power for utilization equipment. So I want to draw your attention to 210.8 item F. Now this one was a result of a death that took place at an outside air condensing unit that was improperly wired to begin with, I believe the study showed. But the argument was if it was GFCI protected, that it could have saved that life, even if it was wired wrong. Again, we can only sometimes protect people from themselves. And if you had a GFCI device, it might have detected an improper wiring. It would have not allowed the circuit to be on, or it would have detected an issue once it took place, and it could have resulted in this person still being with us. Sometimes the quickest way to get something in the NEC is sadly a tragic death or something. So this one is dealing with outdoor outlets. Now this one applies for dwellings, okay? So this is not across the board. This is a dwelling. Although I will remind you that you still have all your other requirements in 210.8b for other than dwelling units that are, for example, outside receptacles, rooftop, all those receptacle requirements still apply. Don't lose sight of that. But this one is dealing with outdoor outlets, and it specifically says all outdoor outlets for dwellings. So let me give you an example. So I have an outside disconnect, simply a pull-out disconnect, and then it feeds an outside air conditioning unit, okay? And so in this case, it supplies it, and it says here in the code, it says all outdoor outlets for dwellings other than those covered in 210.8A3, okay? And then A3 is just normal outdoor receptacle outlets, okay? That's covered already in the code, okay? Because those are types of outlets, receptacle outlets. But here we're talking general outlets in general. It says it says those that are covered in 210.8A3 exception to 3. And of course that exception to 3 is talking about those that are dealing with snow melting and whatnot as well. Okay, so you already got your outdoor requirement, and then of course you've got those that are also there that are an exception because of the fact that they're for outdoor snow melting and whatnot. Okay, so just making it clear, it's saying that are supplied by single-phase branch circuits rated 150 volts to ground or less and 50 amperes or less shall have ground fault circuit interrupter protection for personnel. So this is going to require that you protect that outside circuit, that branch circuit that's going to that disconnect, because that is a branch circuit still. It's no overcurrent protection there. It's just a pull-out disconnect that goes to that air conditioning unit. If it's 50 amperes or less, and it's 150 volts or less to ground, 150 volts to ground or less, then it is going to have to be GFCI protected now. So you're going to have to protect that with a GFCI circuit breaker, because we're talking about an outdoor outlet in this case, not a receptacle outlet. All right. So important to understand that and be aware of that when you're dealing with it. Now, there is another exception to this rule to remember. This is also dealing with other outdoor outlets, but there is an exception. It says, you know what? I just finished telling you all this, but it's saying, you know what? The ground fault circuit interrupter protection shall not be required on lighting outlets other than those covered in 210.8c. Okay, so it's not required for the outdoor lighting outlets, but you do have the crawl space lighting outlets, which does require GFCI protection. So it's just reminding you that your normal lighting outlets that are on the side of your dwelling, that's for your like entry lights, no, we're not talking about those. Okay, but just don't lose sight that the one in the crawl space is still covered, just not those regular lighting outlets that are like at your entryway and things like that. That's what it's saying. Okay, so that is kind of a little bonus that I'll throw out to you. And then the last one that we want to talk about is a calculation one, because I think this is significant not only for you as a journeyman electrician or residential master electrician that are doing residential, but if you're taking exams. And one of those is that in the past, when you're doing a load calculation for your service or feeder, you would have to do 3 VA per square foot, and you would have to go to 220.12, and it would tell you that, and then you would go over to the table 220.12, and it would have the definition. It would say dwelling unit, and that would tell you that it's 3 VA, okay? Well, that's not there anymore. So there's been a change to 220.12, the table. Now residential applications are going to be under 220.14, okay? And under 220.14, it's specifically going to tell you to use 3 VA per square foot. It's going to tell you that the general use receptacles for the bathroom is already figured in there. You don't need to do anything extra. The garage is already figured in there. You don't need to add anything extra. Don't still remember that you still have to have the 1500 VA for your two small appliances, 1500 VA a piece, and your 1500 VA for your laundry. But when it comes to the general use receptacles, like the one in the bathroom and the ones in the garage requirement in 210.11c4, those are already figured in. So you don't have to add anything additional, okay? But all of that's right here, okay? Also, it tells you the receptacles in the front and the back of the dwelling are already figured in. You don't have to add any additional VA for that, okay? So it does everything that it did before. The only thing that it does now is pulls out the need to use 220.12 for your dwelling unit application. And that's for dealing with one family, two family, and multi-family dwellings, okay? It gives you the guidance here to use the 3 VA per square foot, all right? And so that's significant. Now, one of the other significant changes is, and everybody always asks this, what about in the dwelling unit when I was dealing with ceiling fans? Well, typically the motors on those ceiling fans are rated 1/8 horsepower or less, okay? Or they're rated less than 1/8. Let me say it that way. They're not 1/8 horsepower. They're rated less than 1/8 horsepower. And then that's the case, you don't have to add any additional VA to that. That just can be absorbed into the actual calculation for the dwelling unit and that 3 VA per square foot. Okay, you don't have to get complicated. And I get that question a lot, ceiling fans, and people ask about those, and I'm like, no. If they're less than 1/8 horsepower and they're connected to the lighting circuit, which they are, usually the ceiling fan is connected into the lighting circuit for the lighting and the switching and all that, then guess what? No additional VA is needed. It's still 3 VA per square foot. And again, now the other neat thing is we now have 220.11, which is floor area, which now talks about how you calculate that floor area. Okay, so again, for dwelling units, you calculate the area is not to include open porches, garages, and the unused or unfinished spaces that are not adaptable for future use. Okay, so that language is all still there, but now it's kind of separated out. And the beauty of that now is when I'm dealing with dwelling, I don't have to get involved in the table 220.12, okay? I really don't, because that now is made clear that that's dealing for non-dwelling occupancies. We're dealing with a dwelling occupancy. It just makes it a little easier in the National Electrical Code, right? All right, so that's it, folks. That's all of the topics I'm going to cover in this one, kind of give you an overview. Hopefully you got something out of that. Look for more of these top 5 changes to the 2020 code to come your way as I pick other top 5. And you might say, well, what makes those top 5 different than these top 5? I don't know. It's just what I'm doing. I'm calling them the top 5, and that's what I'm doing. Anyway, hopefully you got something out of that. Hopefully you're excited about our live shows that are starting January 4th, 2020 at 8 p.m. Central Standard Time on electricianlive.com. Hopefully you join us there and chime in. Remember, you can call in using Skype. Master the NEC is your ID. If you go to the website, you got a link there. You can just click on the icon for Skype, and you can call directly with that as long as you have Skype loaded on your actual computer, laptop, phone, or whatever. Join us. It'll be fun. And we're not going to talk code. We're going to talk electricians in general, and it ought to be cool. So until next time, folks, stay safe. God bless, and have a wonderful holiday season. You've been listening to Electrician Live with your host, Paul